Okay, we're going to work through problem B here, and there are actually 3 ways to solve this. One of them would be by elimination. A second method would be substitution. And a third method would be equal values, and we'll talk through each of them as possibilities. So for elimination, in all of these, our goal is to go from 2 variables and 2 equations down to 1 variable and 1 equation. And so for elimination, our strategy would be to figure out what we can do to eliminate a variable. When I look at the x's, 15 and 7, they're not really related at all. When I look at 10 and -2, I know I could multiply -2 by 5 to get -10, and then eliminate the y variables. So that's what I'm going to do. I'm going to take the 7x minus 2y equals 24. I'm going to multiply that whole thing by 5. (24 times 5, I believe, is 120. And then I'm going to take, so that was equation 2. I'm going to take the first equation and write it right underneath it. So 15x plus 10y equals -20. And then if I add these 2 equations together, a -10 and a +10, the y's cancel out. And so I'm left with 0y, but I can add 35x and 15x to get 50x. And 120 and -20 to get 100. And then it becomes very easy to solve for x. And then don't forget that you also have to solve for y. A substitution method, if we wanted to use it, would be to get 1 equation set equal to x or set equal to y. And since we've been working with that second equation, let's go ahead and continue to work with that. If I want to get y by itself, which is probably what we've had the most practice with in rewriting linear equations, my first step would be to subtract 7x from both sides. So I am left with -2y equals 24 minus 7x, and then divide by by -2. So I'm left with y equals 24 divided by -2 is -12. And -7 divided by -2 is positive 7/2, or half of 7, which is 3.5x. Now, that's only rearranging 1 equation. What I then have to do to substitute is I have to take this part that's equal to y and plug it into y in this equation. So I'd write it as 15x plus 10 times -12 plus 3.5x equals -20, and then I would solve. So far I'm liking the elimination method better, but let's see. Equal values would be the third, and so in order to use the equal values method, it means that both equations have to be equal to something. And so since they're equal to different things here, -20 and 24, means we'd have to rearrange both equations somehow. And since we've already rearranged this one down here into y equals form, if we can do the same for the other one, then we could set them equal to each other. So I'm going to take the other equation, 15x plus 10y equals -20, and I'm going to solve it for y, which means subtracting 15x from both sides. So I have 10y equals -20 minus 15x. And then I'm going to divide by 10. So y equals -20 divided by 10 is -2. -15 divided by 10 is -1.5. And now I have this equation, whoops, didn't mean to do that. I have this equation that's equal to y, and I have this equation that's equal to y. And since they're both equal to the same thing, I can set them equal to each other. So -12 plus 3.5x equals -2 minus 1.5x, and then I could solve from there. So you have three options to solve this. I know which one I would pick, but that is entirely up to you.